Okay, so now what we're looking at today is we're going to fit a trend line and we're going to do forecasting. So what we're talking about, we were in the last few lessons, we were de-seasonalizing our time series. So we noticed when we had some seasonality in our data, and we were then de-seasonalizing the data. So we went through all that process where we found the seasonal index, and then we de-seasonalized all the data. And then what you can do is we could pop that data into the calculator and get a new trend line. So I'm just going to show you, I've done something on the calculator so that we could see, so you could see. So if we remember, this is what we were talking about before. So we had, it was quarters. So remember, it was summer, winter, autumn, and spring, and it was over 3 years. And I think we were talking about sales. So this was the original time series. So you could see that there was a little bit of peaking every in the third quarter or whatever. So we said there was seasonality. So we found the seasonal index, and then what we did is we de-seasonalized all the data. So I've popped in those values, and you can see there. So the orange, so can you see how it takes away the peak there? So you could technically get the regression line. We could get the regression line for, I think that's the de-seasonalized value, or you could get the regression line for the original time series. But once we've de-seasonalized it, we probably really want to get the equation for the de-seasonalized, because that's now showing us the trend of what's overall happening. So you can see that the orange, it's still got an upward trend, hasn't it? We understand that her sales were peaking every now and then, but overall her business is going up, because I think it was sales at something. All right, so that's what we're sort of looking at today. We're looking at getting the trend line, but sometimes they might not be using the de-seasonalized data. So just be really careful at reading which one they're using, because it will make a difference. All right, so let's have a look here. It says the table below shows the number of female students in Victoria enrolled in at least one subject of maths learning at their year 12 period over 2010 to 2018. Now, it says fit the trend line to the data and interpret the slope. So fitting the trend line, so you can see here is, this is the trend line, okay? They've given it to us. So that's like, this is like my A value and this is the B value. So there's the slope. So if you remember, when you want to draw the line or the trend line on the graph they're given, remember you're going to pick 2 points. So I'm going to pick 2010 and I'm also going to pick 2018. So into the formula, I'm going to find out the number of females when it was 2010 using the equation. So plus, so I'm just using that formula, the trend line, and I'm timesing it by 2010. And I get the answer to be 76964. So if I went up on my graph and I'm looking for 7694, so it's like just underneath. So this graph's pretty small in your notes. On the page it would be much bigger, but we're going to say roughly there. Then I'm going to do it again because you need 2 dots to match up, to line up. So I'm going to use 2018. I'm trying to use ones where it's on the page and within the data, just so I can, so I know that it'll fit on the page. So when I did 2018, I get 83772. So I go up to 200837. So it's a little bit under 84. So there you go. And then what you would do is you'd get your ruler and you would draw your line. So that's me fitting the trend line to the data. I've done that. Okay. Then it asks me to, here we've got to interpret the slope. So then once we go, when we need to interpret the slope, you go find statement that I asked you to copy, and this is a positive gradient, so the slope's positive. So I use the positive statement. So the slope estimates on average. So this is all what you have to write every time. Now you put the RV. So the RV is number of females. So female students. Just going to write that. We know they're studying maths. So the number of female students increase by, and you put the slope number. So I'm just going to write 851 because a female, you don't have a point, something of a female. So I'm just going to leave it like that. When the EV, which is year, increases by 1. So I've copied that from our little statement, and you would have found where you have to change the yellow. So this bit would have been in yellow because you have to change it by, you would have had to put the number in there, and also the EV and the EV unit. All right, so if you go back and look at that, that's what you will do. All right, so then we're asked to forecast. So forecasting essentially would always be extrapolating, isn't it? Because we're forecasting in the future. We're trying to see what happens. And the reason we're doing that, so say if I was forecasting this time now in 2026, because they might want to know, well, if we forecast we're going to have a lot more females, we might need to increase more math teachers or things like that. All right, so let's have a look. So it says, how many students do we predict to be enrolled in year 12 into 2026? So you're just pretty much doing the same. You're just using that trend line. And when we're forecasting, we're assuming that the same trend is going to keep happening, because really it's not always the case. So and that's why it's important they might ask you that, or you just have to say, well, assuming the same trend line happens. So I'm going to round that to a whole number because it's talking about females. So we assume that there'd be 90,580 females studying maths in 2026, because we all know we've already lived through COVID. It would have caused, when you look at stats, when these kids, in the future, when people are looking at stats, we're going to see the trend will drop off. There'll be a big trend in lots of data when that happens, okay, because lots of things happen. So that's when we're forecasting, we're assuming those things are happening. So here's where if we look at it, they're taking into account, this was the deseasonalized data that we looked at before. So here's that girl's Mickey's shop. And so if you look, it's really important that you highlight this. It says these are the deseasonalized quarterly sales. So can you guys write next to this, especially next to this table, that it's the deseasonalized values? They've sort of, this example, they've sort of stuffed up there. They should have that's deseasonalized sales, okay? Because the real sales is what we would call sales. So we're doing that. Anyway, they've graphed it, and here it is. And so here as well, call this the deseasonalized sales. So this is a formula to find the deseasonalized value, not the actual sales. All right, so we just have to be careful. They sort of stuff that up. So once again, in this question here, when it says what sales, what deseasonalized sale, okay? Because, and the reason I'm saying it should have been that, because it says what sales do we predict Mickey's shop to have, because you couldn't predict an actual sale because you're predicting in the future. So let's just make sure that. Now, they want winter of year 04. So if you look at it, this was, so it was using the data before. So year 1 was, I believe, I can't remember. So year 1 was here. So we've got year 1, year 2. So we have 3 years of data. So if you think about a year 1, 2, 3, and 4, if you had the seasons, summer, autumn, winter, spring, that's how they worked it out. So the quarters in year 1 was 1, 2, 3, 4. Then the quarters in year 2 was 5, 6, 7, 8. The quarters in 3 was 9, 10, 11, 12. And the quarters in 4 would have been 13, 14, 15, 16. So when they want winter of year 4, it's actually quarter 14 that we need, because this formula is we need to use the quarter. So we're going to say the deseasonalized sales is 838.0 plus. So I'm just using the formula they gave me. And then I have to pick the quarter, which was 15, sorry. Did I say quarter 15? I'm sorry. 15. I said 14, but I should say 15. Okay, so it ends up being 1319. And so there's that. So she can know that in the next year, she could predict, all right, I'm going to need in winter, I need about 1319 of stock. It's to help her prepare, because, stock might take a while to get in, or things are getting made, whatever she's doing there.